Hello, Carson and Artanian here with linear exponential functions.
Welcome.
Okay, well first we have a linear growth. Leonardo is buying a house. Company A wants him to put a down payment of $1,000 and then $50 a month. Company B wants a down payment of $1,220 a month. If he is going to pay for 12 months, which is the better deal? And how many months will he have paid for if he's paying for $1,700 for the better company? Well, that would be the table. And as you can see at the end of the table, at 12 months, company B is the better answer. The now next equations for company A would be next equals now plus 50 and the start is 1,000. And for company B it would be next equals now plus 20 and the start is 1,200. The other equations would be for company A, y equals 50x plus 1,000. Company B would be y equals 20x plus 1,200. And then for the second question, when he is paying $1,700 for company B, it will be he will have been paying for 25 months. This is a graph. As you can see, that is where it intersects, and that's when it starts being cheaper. And now we have our linear decay problem. Carson has a Bugatti. The cost of the Bugatti is $85 million. Every year, his Bugatti loses $5 million. How much will Carson's Bugatti be worth in 13 years? And when will the Bugatti be worth $15 million? Well, as you can see, the table says that at 13 years, it will be $20. So that's the answer to question 1. $20 million. Not $20. That would be very, very cheap. The now next equation would be next equals now minus 5. And the start is 85 million. Then you have this equation, and it is y equals negative 5x plus b. And the answer to the second question would be after 14 months, his Bugatti be worth $15 million. And here's the graph. Is going down, and there we go. Technically, it should not be hitting the line, but as you can see, we started the graph at 20 million. And now we have the exponential growth.
This is where I come in. Juan bought $2,000 in stocks, and it's increasing by 20% every month. How much will he have in 2 years? And at what point will he have $20,000? The equation is the next now equation is next equals now times 1.2, because it is increasing by 20. And the start is 2,000. The explicit equation is y equals 2,000 parentheses 1.2 parentheses to the x, which can be wherever you want to go. Alright, up here we have our table. This is the months, that's the money, and it goes up to 9. Thank you. And then we can see Juan's money in the graph here. It is increasing at an exponential rate. The answer to the first question is Juan will have $158,993.69 in 2 years. This is the work, right here. And for the second problem, Juan will have $20,000 in 13 months. Here's the work. Plug and play. That's what it is. It's plug and play. This is exponential decay. Juanita owns a snake pet shop, but a disease is spreading in her snakes. She had 150 healthy snakes, but every week an extra 50% has been infected. How many snakes will be healthy in 5 weeks? And at what time will no snakes be healthy? Excuse me. Not now. The next now equation is next equals now times 0.5, and the start is 150. The explicit equation is 150 parentheses 0.5 parentheses to the x. You do not have the 1. You do not have the 1 point because it is decreasing and not increasing, so you don't need the original value. This is the table for Juanita's snakes. It does not actually end at 0 because exponential decay can never go to 0, but it was 0.5 and you cannot have half a snake. Well, you can, but not in a pet shop. This is the graph over here, if you'll look, thank you, and it goes down fairly quickly. You can see it doesn't quite reach 0. Now the answers, and this is all the work for the answers that you need, as long as the graph goes up to 8, or the table. Now the answers, down here, the answer to number 1 is Juanita will have 4 healthy snakes in 5 weeks, only 4 left. And the answer to number 2 is Juanita will have no more healthy snakes on the 8th week. So, half a healthy snake, which is 0. We're rounding down.
Well, this has been our word problems for our linear and exponential function problems. Thank you for watching. See you next time.